Okay, so Unity is a program that can be used to develop live video games for a variety of platforms. People use it for making games for phones, for computers, for Fulldome, for VR. There's just a variety of applications for it. Really, anything that you can think of, you can pretty much do with it because it's a fully scriptable system. If you know how to use C#, which is a fairly simple language to pick up, you can make modifications to scripts inside of the Unity editor. And the Unity editor should be thought of as like a glue system so that you can take a variety of kinds of art and glue them together into a presentation that has all of the interactive components that you need. If you think of it that way, then do all of your creation in external assemblies like Blender or Photoshop or Audacity for different types of content. Then you'll be able to make your things, bring them into Blender or bring them into Unity, and then build your game there. I made a couple of components to make things easier for everybody in publishing content on Fulldome Productions. One of the things that I made is a camera that's available. So first, get Unity3D if you're following along. Download a copy. I hope you have a copy of it already because it takes a while to download and I'm not going to wait for you. I'm sorry. So if you don't have it already, then just pay attention and try to remember. Everything is going to be available on cosmicorbiters.com. So if you'd like to come back to go over my presentation, you can get all of this information on my own website, cosmicorbiters.com, which is also a video game that I made for Fulldome. The first download past Unity is this Saturn V model. So if you go to NASA, there's a whole collection of free models that you can grab. And we're going to animate a launch of the Saturn V rocket and the Saturn V gantry system. And this is going to be a really simple animation without any audio or anything like that. It's just a demonstration of how to do one animation using the camera that I developed. This is the gantry model. So if you're following along, go to NASA's website, grab that Saturn rocket, and then grab the gantry. And then this is the camera that I mentioned earlier. It's on my GitHub account, and this is another component that Paul Bork developed for everybody. And got to thank Paul Bork. He's really done a lot of stuff for everybody in this industry. This is a higher res version of the camera. It's just got some settings changed and a different set of render textures. It's been updated for the newer versions of Unity that are available. It just does a kind of a service for what it is that people are doing. I use this camera in lots of applications, and it uses, and I'm going to explain it real quick. Like their diagram here, it has a camera that is facing in every single one of these directions. And in this case, the Unity camera has a set of 4 cameras that are facing one corner, basically. So there's 2 that face either side, and 1 that faces the back, and 1 that faces forward. And so this is your whole dome shape as the camera sees it, all on diagonals. These the type of showing that we get there is a Dome Master content item, which is a fisheye, commonly known as. But it's actually been a cube map that has been reduced to 4 points. And that live cube map has, each portion of it is 2K in this camera. And that makes for a total of 4K for the entire production, 4K by 4K. I'm going to leave all of the links up there for a moment. And I'm going to launch a new project in Unity. So I use Unity Hub, and I'm going to bring the interface over here for you all to see. I'm going to try to bring the interface over here for you all to see. Oops, getting ahead of myself. So this is Unity Hub. I'm going to create a new project in it. It just keeps track of multiple Unity installs. So if you just have Unity, you can open up Unity and say new project. And we're going to go ahead and get into that new project. It asks you a few questions when you're starting a new project about things that you'd like to include in it. We're not going to bother including anything. Once it starts up, we're going to drag the downloads of the Dome Master component that we had earlier into the Unity interface. Guys don't mind, I'm going to switch sides of the podium here so I can see what's going on and talk to you all at the same time. Okay, and we're still launching Unity. It takes it a minute. My computer isn't so fast. Oh, no, it's over here on this screen. Okay, so this is the Unity interface. I'm going to go over the windows real quick. It's kind of compressed here. The hierarchy area is where it shows what is in your current build. Like your scene, as you make it, is full of the hierarchy. Your project has all of the things that you've dropped into your project and made available to it. We're going to drop our models into the project folder to be able to put them into our scene, which will include them in the hierarchy. Over here, there's the scene, the asset store, and the animator listed. There's also a game window that isn't shown right there. But when we hit play, it'll switch over to the game window as our primary window. And that shows what's going on, basically, in all of our output. So I'm going to go ahead and go to the folder of items that I've downloaded. And the first one is the Dome Master demo camera. And we can just take that and drag it into the project view over here. And it will import all of those components. So there's the Dome Master. And here is the Saturn 5C folder that I downloaded. And now we've got that. And here is the gantry. And we're just going to drop that into the scene. Or into the project. Big difference between project and the scene. You've got to remember not to confuse everybody. So now that we have all of these objects, we're going to delete the main camera that is part of the scene. So we're going to select that and press the Command Delete button or Control Delete, depending on where you're at. And then we're going to open Dome Master 4K here, and it has a couple of and we're going to open Dome Master 4K. Do I have another? Reset the default layout just in case the. Okay, so within Dome Master 4K, I'm so sorry. So I just reset my layout and it changed the whole layout. So if everybody was getting used to it from there, this is a big change now. And this is probably actually what you were dealing with anyway. So it's a good thing to have gone back to. So up here on the top, there where it says default, these are all the layouts that you could possibly have Unity in. You can change how everything looks on your view and then save it. And I do that all the time. But I've just reverted it back over to default, where the project is down here and the hierarchy is up here. So I can now drag out of this project into this hierarchy folder. So I'm going to open these prefabs. I'm going to grab both of the parts of the Dome Master camera and drag them each into the scene. So there are two parts that are required. This part assembles all of the camera outputs. You see each of the four meshes here. Each of those are a different mesh that assembles that direction that the camera looks. And it assembles it all on a flat plane so that another orthographic camera, that's this one right here, can, so this orthographic camera can observe the whole space. And that outputs this fisheye view. So I'm going to go ahead and hit the play button up here at the top. and that'll show us that in game view we have a single fisheye view. Now this is a live camera output, which like you'll see in Vuo or in now Blender with the Eevee render. You'll get 60 frames per second off the piece of the computer. You have to be kind of careful about the number of polygons you put into a scene, because you're using at this point 4 cameras in the scene, and all 4 of those cameras have to have the polygon rendered for their perspective, which takes up some juice. So now that we have our cameras in the scene, I'm going to send this camera way out on the x-axis, just to separate it physically, so that we don't have it in our scene area. And then I'm going to go back into our assets, and that Saturn V that we got earlier is going to go into our hierarchy. So I'll just drop it in there, and so is the gantry. So we now have a Saturn V rocket and the gantry in our scene view. And this is an editor view that you can zoom in and out using by scrolling, or using both fingers, depending on where you're at with your type of computer. And you can click on this navigator to change your view. And I'm going to move the Saturn V rocket onto the launch pad in the scene. So I've got to move it down slightly, and a little bit over, and move it up. Now I don't have to be super precise about this, because this is just animation movements that we're doing right here. But now we have all of the objects that we'd like to animate in the scene. Now it's a good idea to do all of your animations within sub-objects of a given object and put your animation on that parent. So what we're going to do is create a new object in the hierarchy by going up to Create up here and say Create Empty. It should create an empty with a transform of 0, 0, and 0 and scale of 1, 1, 1. If that's not set the way that looks right there, go ahead and hit the reset button on this gear up here. And then take the Saturn V and drop it into the game object that you created. And also take this 180K 4K dome camera and drop it into the game object that you created. We're going to animate both of these objects with our animation. And then you can click on game object and rename it by either pressing enter or clicking on it again. We're going to call this animated rocket. Wow, okay, caps lock on. We're going to shout it. Okay, and now with the animated rocket selected, I'd like you to go down to this view down here, right click on where it says console and say add tab. Oh, add tab, and you want the animation tab. Okay, so now that we've got the animation tab, we can click on the create with the animated rocket item selected. We can click on create, and this is going to allow us to create a rocket animation or rocklet animation, depending on what you want to call it. I like rocklets. So this is an animation timeline. It first starts off in a 1 second range. We're going to build an animation that lasts about 30 seconds, so I want you to zoom out on the animation timeline. And then when you have 30 seconds indicated for the max length of the timeline, press this record button at the top of the animation. Now, we're currently at the very beginning of the animation. The animation is at 0 on the timeline. So we're going to click on the Saturn rocket, and we're going to change its transform. Oh my gosh, what is going on?
Your projector is running 800 by 600 resolution.
Yeah, okay. Okay, so we're going to set this up so its Y position is going to be the animated part. So we're going to make this 1, and that is going to record the property. So see how it added position down here? And I'm going to change that back to 1.5 because that's where a good start for it. And then we're also going to animate this dome camera and its movement relative to the Saturn V. So we're going to go ahead and click on it and set it for 1, which will record the value over there, and then set it back to 0 again, because 0 is a good value for it to start from. And then click on the end of the animation out here at 30 seconds to move our timeline. And I'm going to go back over to the Saturn rocket, and its position at the end of 30 seconds should be 1,000. And so that causes it to leave the gantry. And then we can take the camera over here and set it for 1,008. So that's going to leave it slightly higher than the rocket at the very end of the animation. And then we can click on stop on our animator over here and go back to the very beginning of it in order to get our rocket back. And we can actually now play our animation. So Unity is going to automatically play animations over and over again. So we're going to get a rocket launch. And oh, we didn't move the relative location of the camera inside the pivot. So it's just going to take off and be next to our camera the entire time. We've got a fisheye camera though, so we're going to get a nice tour of the rocket during the launch because we moved up along its length. If we want to get some relative movement going though, I suppose we're going to have to tilt the camera to view. So I'm going to go ahead and stop this animation. And go back into game view, and we're going to move this. The offset here can be 5. Go back over to scene and view from the top. And this camera is going to be all these lines that indicate, because it's 4 cameras that are combined together. You can move it on its pivot point here, and since that's a sub-object, that's always going to stay consistent with its distance from the parent object. Ditto with the rotation. So if we want to rotate this on its side by 20 degrees, a lot of domes will give us that kind of a format. Then we would have this kind of a view for our rocket launch. And excuse my computer, it's very slow. 1 second per frame is about what I can manage here. But that's our Saturn leaving the gantry, and it will continue up for about 30 seconds, and then start the animation sequence back over again. And this is really simple stuff. I didn't add any controls to it. Unity has support for joysticks, for a variety of inputs. I use an application for input called Slab Fondler, which I'll be showing people at a demonstration later on today. But yeah, we're just going to start. They'll just cycle through this animation over and over again. You can change that on the object itself. You can tell it not to animate automatically, and then use a script call for each of your animation calls for the various things you'd like to add. But this is the most simple way of getting started with Unity and building animations in there. And yeah, it uses, and so with this information, you should be able to use the dome camera to build out your own presentations and build your own graphics and include those and call the animations on those. So it's really a toolkit for you to use to get all your own stuff together. And yeah, that is my presentation. I'll go ahead and bring back up the slides here. We just played it, and yeah, my name is Belin Fieldson, and does anybody have any questions about what we just went over? No? Adam?
I do have one. So Paul's camera looks really cool. I didn't realize you had to import something. Just as a Unity roadmap question, do they plan to add their own fisheye cameras?
No.
Okay.
Yeah. the camera that's built into Unity, you can actually take the field of view up to 120 degrees. And the first game that I made, I took the camera to 120 degrees, and then I masked off a circle, and I put some starships that moved around the scene, and that worked really, really well for making it dome oriented. I think that might be because our dome, the Tri-Dome, is a 160-degree dome instead of a 180-degree dome. So the field of view matched really well with the physical mapping. But it's totally possible to use that single camera technique as long as you don't need super accurate representation. Yes?
I wonder about, you can change the field of view up to 120 degrees if you could, you're rendering 4 frames for each frame in the game with your camera, if you could use less than 4 just to make it a little bit easier on the computer.
Oh yeah,
so you can get more out of
yeah.
it.
If you're using low-end computers, then it's really a good idea to stick with the 120-degree single camera. If you, as a matter of fact, if you don't care about formatting to the dome, then you can use a regular camera and output. It's just going to look strange at the edges. And there are some shaders that will take care of that on their own, like where the shader will change the way that it represents depending on where it's physically located relative to the camera. So some items will show their own fisheyes in Unity view. This camera is generic and will work in almost any circumstance, but it's slow. And there are some better solutions out there if you're doing something really specific and are able to build all of your own graphics. Yes?
So if you wanted to limit it to 120, you could just have a margin around the dome if you had a 180 projector, or?
Yeah. If you set your single camera to a 120-degree view and then add a mask that is a round mask, then it works great on projection. And yeah, it's I would say it's about as good as sticking GoPro footage directly up on the dome because it's got the same kind of field of view. If you're familiar with trying to directly convert GoPro footage.
So Artie Perman's Unity expert isn't here, but if I go back to him, because he hasn't done any work in Fulldome, the main thing that he should look at is the camera.
Yeah, that camera that I got from, well, first Paul Bork and then Charles Veazey modified it for the IAAA, the Indian Affairs group, and that was a few years ago, and so the updates that I did recently should help you be able to use it with modern versions of Unity.
Yeah, we used the camera done a lot. We had people that came in that already knew Unity, and we were able to just be like, here is this camera package.
Awesome.
We don't know much about Unity, but you do. Here's this camera package, and they were able to just run with it. And because it fixed the output problems, they were able to, do everything they needed to do. Just get another double.
Yeah. Instead of having to learn all of the steps, which my gosh, it was like getting to the point where I know how to do this well enough to show everybody. Took me a year of research, and nobody's got time for that. So like you're all trying to produce things, and you have content that you want to move in there, and this is a really fast way of going about it. Sorry about that. I didn't realize we were blacked out back here. Any other questions? Yes.
So, Paul, I guess, for people doing this in domes, so what last year, Evanston Sutherland was showing Unity running in their planetarium system, if I understood right, in Star 6. Is anybody actually using that? How I would,
Not a planetarium, I mean,
whether in a dome somehow?
So I used Unity, and I forget if it was Belin's camera or not, but it was a fisheye camera. And so I had it hooked up to a Mac Pro, and I was using some VJ software to output the fisheye to slice it to different projectors. I was using Fulldome VJ, and I actually made an interactive, like a space video game with a joystick and everything. People could take turns flying the dome around through space. And it was all, you know, live, and it was actually Unity live, so I can go into the Unity editor while they were playing the game and drag objects around and kind of mess with them and play God per se. But it was all live, and it was using the Blending software over a Siphon output, so I had Unity set up for the camera to output to Siphon, so the Blending application could pick up the feed and then split it between the projectors. I'm not sure how that applies to actual planetarium, but
It's actually a really good point. At our planetarium in Fort Collins, we have to go through all sorts of we have to make all sorts of changes to systems in order to have live support. So you guys all are operating planetariums of various sizes, people who have planetariums operate, and those have multiple projectors in them. So you've got to split all of the content. So just getting a Dome Master out of a live system is not enough for everyone. Not everybody's got super high speed capture cards going on their planetarium hardware. So at ours, what we had to do was hook up the secondary input on all of the projectors to a second computer. And that computer has 2 video cards in it and is capable of running all of the projectors at the same time at their full resolution. And what I did was I built another piece of software in Unity, and I can go over that with anybody who is interested in building projection management software in Unity. This isn't exactly the forum where I can explain that sort of thing to folks, but if you'd like to talk about it separately, just come on over and talk.